All right, let's jump straight into this explainer. We're looking at a massive trap today, one that literally costs thousands of Cambridge IGCSE computer science students their top grades every single year. We are talking about that frustrating gap between what you think an examiner wants to hear and the incredibly precise technical language they're actually demanding. So today, we're cracking the 0478 mark scheme. We'll specifically focus on programming and future concepts so you can strut into that exam hall with absolute total confidence. Take a really good look at this question. If you don't know the exact command word constraints for syllabus 0478, your natural instinct is going to lead you straight into an examiner's trap. What is the link between a web browser and a search engine? I mean, it sounds like an everyday question, right? Most of us use these two technologies interchangeably in normal conversation. But in a computer science exam, relying on your everyday, casual vocabulary is exactly what the exam board is hoping you'll do, just so they can test your true technical depth. Now this right here, classic trap, 0 marks. It fundamentally confuses two completely different pieces of software. Let's read it again. A web browser searches the internet for information for the user. It sounds perfectly logical to a layperson, but computationally, it is completely 100% inaccurate. A browser does not search, period. And if you write this down, the examiner immediately knows you haven't mastered the core definitions. To fix mistakes like this, we've got to decode the assessment objectives and learn the secret language of the Cambridge mark scheme. Because getting top marks isn't just about memorizing facts, it's about structuring those facts to perfectly align with their grading rubric.
So let's move into our first section, the secret examiner language.
To actually lock down those marks, you need this 4-step framework. It basically forces you to ditch the generic guesses and directly apply your knowledge to the specific scenario nouns in the exam question. First up, you state the concept clearly. Second, you pull evidence or data directly from the question prompt itself. Third, you apply scientific reasoning to explain exactly how it works. And fourth, you lock the whole thing in with precise examiner wording. This structured approach is your absolute best shield against losing silly, avoidable marks.
Moving right along to Section 2, Mastering Web Browsers.
Let's put that framework to work and strip away all those casual conversational definitions, replacing them with purely technical ones. Notice how we are entirely dropping the word search here. A browser is specifically an application that acts as a translator for HTML code and cascading style sheets, displaying them as the web pages you actually see. When a server sends a file, your browser reads those tags, interprets the JavaScript, and renders the visual layout. It's a retrieval and display engine. It is not a search tool.
And this split perfectly shows the difference. If you just write "it finds websites," you are leaving serious points on the table. But when you specify that it translates HTML code from a web server to display a page, boom, you are checking off the exact technical mechanisms the examiner is holding the mark scheme for.
On the flip side, a search engine is not the application itself. It's a tool accessed through the browser that relies on keywords to return a list of URLs, while DNS name servers act kind of like a phone book to locate the actual servers. You type in a topic, the search engine queries its massive database, and it hands you back the uniform resource locators, the URLs. The browser then takes over to retrieve and translate the code from those URLs. Two highly distinct jobs.
Now, in just a minute, I'm going to reveal this one hidden examiner clue about scenario constraints that literally dictates whether you get full marks or a big fat 0. But first, you need to see how our framework applies to algorithms. This hidden clue is a real game changer for how you'll approach paper 2. But let's lay down just a bit more groundwork before it makes total sense.
Okay, Section 3, Upgrading Linear Search.
All right, stepping away from the internet for a second, let's dive into the internal logic of your programs. Algorithmic thinking is foundational here, and a linear search is pretty much the most straightforward method. It iterates through every single item one by one until a match is obtained, or the list just ends. It doesn't jump around, it doesn't guess. It is a highly methodical, systematic process that plows from the very beginning of an array straight through to the end.
So let's visualize this. We're looking at a linear search iterating through an array of game scores, starting from index 1 and moving downward. Check out these values. Imagine the computer's pointer starting at position 1, evaluating if 545 is the target data. It's not, right? So it loops and moves to position 2, checking 003, and it just keeps evaluating step by step.
All right, quick pause and predict challenge for you. Trace this algorithm in your head and tell me exactly how many comparisons the computer must make before it stops. Let's run the mental trace table together.
Start at position 1, count down. How many operations occur before that target score of 127 is isolated?
And it's 6. Because the linear search checks sequentially, it has to evaluate positions 1 through 5 as false before successfully matching the data down at position 6. That is 6 distinct logical comparisons. If you were drawing a trace table for this algorithm in the exam, you'd literally have to document every single one of those steps to prove you actually understand the iteration.
Check out the vocabulary upgrade here, explicitly mentioning the iteration, the array index, and the termination condition. That's what earns top marks. Writing, "it finds the number," is how an everyday user describes software. But saying, "a loop iterates from array index 1 to 6, then terminates," is how a programmer describes software. You absolutely must adopt the programmer's vocabulary to secure these grades.
Which brings us to Section 4, the final exam challenge.
All right, we're finally closing the loop on that secret examiner clue I teased earlier. This is where the whole shebang comes together. The precision, the vocabulary, the strategy. The hidden key to unlocking full marks in Paper 2 is that you can never, ever use generic terms. Your answers, your variables, your trace tables, they must use the exact nouns provided in the question scenario. So use game scores instead of just data. If the exam question is about processing a bus or train system to figure out fares, your variables in pseudocode shouldn't be X and Y. They need to be adult fare or child fare. The examiner wants hard proof that you're solving their specific problem, not just lazily reciting a memorized textbook example.
So, to wrap up this explainer, you've got to memorize these strict definitions and always frame your technical reasoning around the precise data the examiner hands you. Remember your 4-step framework. A browser is an HTML translator, full stop. A search engine is a URL finder via keywords. A linear search requires sequential iteration until a match. And your absolute golden rule for Paper 2, apply those exact scenario nouns. I am going to leave you with this final challenge to really chew on. Think hard about those termination conditions we talked about. And make sure to join us in our next explainer where we're going to decode the exact pseudocode needed to answer this very question. See you in the next one.